Welcome to my video on physics of uniform motion. Here's the problem. Tom and his friends want to take his motorboat from the dock to the beach that is 24 miles upriver. If the river is flowing 3 miles per hour and Tom wants to make the round trip in 6 hours, how fast should he drive the boat? So let's take a look at our diagram here. We see what we do know. We do know it's going to be 24 miles from the dock to the beach, and the river is flowing 3 miles per hour. And here's Tom and his friends in their boat. So that's the information we do know, and it's going to take 6 hours. So let's start writing down. When we have a problem, I always start with writing down what we do know. And what we do know is that the total trip is equal to 24 plus 24, which is equal to 48 miles. We know that's how far the boat ride is going to be. And the total time, this doesn't account for time at the beach, but the time of the boat is 6 hours. And then the rate of the river is equal to 3 miles per hour. And basic physics tells us that the distance is equal to the rate times the time. That's our basic equation, our rate equation. Solving for that, we get the distance is, the time is equal to distance divided by the rate. R is equal to the rate of the boat relative to the water. And then we also have a velocity of the boat, and that's relative to land. In other words, the speedometer in the boat is going to read one speed, and then somebody clocking the boat from the shore will read another speed. So this is inside the boat, and this is on the land. So going upstream, that's against the flow of the water. So the velocity viewed from the land is equal to the rate minus 3 miles per hour, because we're going against the water. Now we're going with the water, with the flow, going downstream. Velocity downstream is equal to rate plus 3, and that's in miles per hour. So that's kind of what we do know, just looking at the problem. Now what we want to do is we want to break this problem up into really two segments, the upstream and the downstream. But we know the total time is not going to change. Now using our basic rate equation, we know the distance is 24 miles, and this is going to be going upstream against the river. Our velocity is rate r minus 3, and then plus the distance, or the time going downstream with the river. So it's r plus 3, that's our velocity. So now we've got one equation we can solve for r. Now our physics problem is becoming a math problem now, and so that's what we need to work on. So we've got the basic equation, 6 is equal to 24 divided by r minus 3 plus 24 times r plus 3. Now to get rid of the fraction, or the expressions in the denominator, we just multiply both sides by r minus 3 times r plus 3. So on the left-hand side, we're going to get 6 r minus 3 times r plus 3 is equal to 24 times r minus 3 times r plus 3 divided by r minus 3 plus 24 times r minus 3 times r plus 3 divided by r plus 3. Now terms are going to cancel out. So the r minus 3 goes away there, r plus 3 goes away there, and we see that we've got a 6, which will divide into 24, so we can get rid of divide everything by 6 now. So that goes away. The 24 becomes a 4. And this 24 becomes a 4. So now let's rewrite our equation here. It looks a little messy. R minus 3 times R plus 3 is equal to 4R plus 3 plus 4 times R minus 3. Now we're going to expand on the left-hand side using the FOIL, the outer, inner, last method of multiplication. So what we're going to do, so on the first was going to be these two terms right here. I also have a video on this if you want to follow up on this a little bit. I'll put a link in the back. So that's r squared. Now the outer is plus 3r, and then the inner minus 3r, and then the last is minus 3 times 3. So that's on the left-hand side. Now let's multiply these terms out. So we got 4r plus 12 plus 4r minus 12. Now we can start canceling things out and simplifying. These plus 3r minus 3r cancels. We got 12 minus 12. So let's just combine terms. So now we've got 8r is equal to r squared minus 9. So we can rewrite that. We got r squared and then we'll bring the 8 to this side over here, so it becomes a minus 8r minus 9 is equal to 0. So there's our quadratic. We want to try to solve that quadratic equation. Do kind of a brute force approach. We're going to use a quadratic equation. It factors more simply, but we're just going to go through the process of using the quadratic equation. So use the quadratic equation. So in this case, then the general form is ax squared plus bx plus c is equal to 0. So equating like terms, a is equal to 1. So that's the coefficient in front of the r squared. B is equal to minus 8, because that's the coefficient in front of the r. And c is equal to minus 9. That is the constant term, c. So our quadratic formula becomes r is equal to minus b plus or minus the square root 4, b squared minus 4ac divided by 2a. Now let's put those terms in this and see what comes out. Okay, we know b is minus 8, so minus b would be plus 8, plus or minus. Now the square root of b squared is minus 8 quantity squared, which is 64, minus 4, a is 1, c is minus 9. And the denominator, we have 2 times 1, because a is equal to 1. Let's simplify this further. So we've got 8 plus or minus. Now 8 squared is 64. We're inside the square root sign, so it's 64, and we've got minus 9 times 1 times minus 4, and that is going to be a plus 36, and then divided by 2. Okay, so we get 8 plus or minus 64 plus 36 is 100, divided by 2. Simplifying this even further, so it's 8 plus or minus the square root of 100 is 10, divided by 2. So we get 2 roots. So 8 plus 10 is 18, divided by 2 is 9. And then we get 8 minus 10 is minus 2 divided by 2, which is a minus 1. Now we need to put back on our physics cap again and realize that this is a non-physical solution. We call those non-physical. Just doesn't make sense. You can't go backwards in the boat and go up. make your trip. So the rate is equal to 9 miles per hour. That's how fast Tom needs to set the boat on the speedometer so that they can make the round trip in 6 hours and travel the 48 miles. Well, I hope you got something out of this video, and if you did, give me a like, a thumbs up, subscribe to my channel. Well, thank you for watching.